Today we're going to talk about solving equations with multiple logarithms. So there's going to be more than one log on either side of the equal sign. So example 1, we have log base 5 of x plus 6 plus log base 5 of x plus 2 equals 1. First, let's look at the domain of these. And so we know that everything inside of the logarithm has to be greater than 0. So we're going to have x plus 6 is greater than 0. So subtracting 6 from both sides, we get x is greater than -1. And we have x plus 2 is greater than 0. So we get x is greater than -2. And this means that any solution must satisfy that x is greater than -2. To obtain an exact solution, we need to express the left side as a single logarithm. So we're going to get this as one logarithm. We're going to use our log properties. And so we know that log base a of m plus log base a of n equals log base a of m times n. And remember, the bases have to be the same. So we're going to have log base 5 of, we're going to multiply x plus 6 times x plus 2. So when we are adding logarithms, we multiply their insides. This is going to equal 1. And now we're going to change to an exponential form. So we're going to have our inside, x plus 6 times x plus 2 equals our base to the first power. And 5 to the first power is just 5. So we're going to FOIL. So we're going to get x squared plus 8x plus 12 equals 5. And now we're going to simplify. So we're going to subtract 5 from both sides. And we're going to get x squared plus 8x plus 7 equals 0. And now we can factor. And we factor and we get x plus 7 and x plus 1 equals 0. And now we can set each one of these equal to 0. So we get x plus 7 equals 0 or x plus 1 equals 0. So we get x either equals -7 or x equals -1. And we notice that x minus 1 satisfies our restriction that x has to be greater than -2, but x minus 7 does not, so this is not a solution. So the only solution is x equals -1, and our solution set is squirrely brackets -1. Now we have a second example. We have natural log of x equals natural log of x plus 6 minus natural log of x minus 4. So we're going to talk about the domain again. So we know that everything inside the natural log has to be greater than 0. So we're going to have x has to be greater than 0, and we're going to have x plus 6 has to be greater than 0, which is x has to be greater than -6. And we're going to have x minus 4 has to be greater than 0, which is x has to be greater than 4. So we know that the result is the domain of the variable here is x has to be greater than 4 for any solutions. So we begin the solution by expressing the right side as a single logarithm. And so we're going to keep the left side the same, so we're going to have natural log of x equals, and so when we have a difference, we're going to divide. So we're going to have natural log of x plus 6 over x minus 4. And that's by our log properties, our difference of log properties. And they have to have the same base, don't forget that. So now, since we have natural log on both sides, we can just cancel those and have x equals x plus 6 over x minus 4. And that's also a log property that we have. And so we're going to multiply both sides by x minus 4. We're going to get x squared minus 4x equals x plus 6. And now we're going to simplify. So we're going to subtract x and subtract 6 from both sides. We're going to get x squared minus 5x minus 6 equals 0. And we're going to factor. We're going to get x minus 6 and x plus 1. You can check my work. And now we're going to set these both equal to 0 by the zero product property. So we're going to x minus 6 equals 0, or x plus 1 equals 0. So we're going to have x equals 6, or x equals -1. And since the domain of variables is x is greater than 4, we discard this x minus 1 because it does not fit in the domain, so it's extraneous solution. So the only solution is x equals 6, and our solution set is square root bracket 6.